Welcome to this series exploring innovation, progress and achievement using a technocentric paradigm by Ash Stuart.
You may want to also read Ash's original Substack article for the best experience, including footnotes and other details.
Episode 32, Taming the Unknown, the Queen of the Sciences, a study of one of the greatest feats of solving problem-solving. In episode 24, Reckoning Reality's True Rules, I reiterated a claim that mathematics was the queen of the sciences. I went so far as to proclaim, mathematics, at its most fundamental level, is a tool that not only allows us to represent reality, but with its sheer predictive power, offers us the best available means to find solutions. I'll now show you why, with real-world examples and in a way that even the most ardent math hater will make sense of it. Well, especially someone who has feared the subject so far. Give me a chance to demonstrate its beauty.
Let's first check out what our fictional friends are up to lately.
Steve and Brian are at the local tavern. It's Thursday evening, and things have been going well lately. They're in a chipper mood. They've now had a few drinks, and things are getting merrier. Brian is bragging about some of the recent breakthroughs. Remember what they are? First, it's just between him and Steve, but as time passes, to some of the crowd around. Eventually, he gets into a bit of a bragging match with this finely dressed gentleman at the next table. Steve tries to urge caution, but Brian's already gone big-time braggadocio, buoyed by the achievements we saw in episode 28 and taking all the credit for himself. Innovation is more often teamwork, as I've often emphasized. Brian's been going on to this gentleman like how good he is at math and all that jazz. At some point, it seems that his interlocutor's patience snaps. He's like, "Listen, fella, if you're that good, we shall test this out. On Monday, you shall report to the magistrate at the town court at 10 in the morning sharp, and when the proceedings commence, I'll give you a mathematical puzzle to solve. If you solve it, I'll give you a portion of my own commission and every other week. But if you fail, you'll have the pleasure of being volunteered to that damn construction project, of course, involving a whole lot of heavy mud carrying, stone lifting, and bricklaying." Steve, Brenda, and Irene are like, "Oh no, what has Brian gotten himself into once again?" But Brian can't back out of it. For this is the First Lord of the local Duke, the most powerful guy in the local area, next to the Duke himself. Though he conceals his own concern, the First Lord has quite a pressing problem, which, the next morning, Brenda and Irene, being more sober than our dudes, bring home in all its glorious detail after a visit to the First Lord's office. Here's the challenge that Brian and the rest of our gang are confronted with. Every fortnight, the Duke receives a large sum of money, say proceedings of tax or tribute or something else. I'm not good at fiction, I'm a nerd, indulge me here. Which he has to divide amongst himself, his 2 brothers, his 3 sisters, and with the First Lord guaranteed a cut for his services in the matter. And here's the rub. It has to be in exact, predefined proportions to each party. Otherwise, all hell will break loose. The exact breakdown. From the overall pot, the Duke gets twice what each of his 2 brothers get. The 3 sisters each get a half of what each of those 2 brothers get. And the commission for the First Lord is an eighth of the total pot, marked away initially since he has to manage the entire affair. Brian and co. have been told in clear terms by now that they will be told the exact quantity to be divvied up in this way. Only on Monday morning. It will not be known earlier, and that Brian will have to, within an hour, produce the correct answers along with the full justification. If he succeeds this Monday, the First Lord has promised him the post of the Chief Reckoner under his employ, alongside a tenth of his own commission, that eighth, to Brian in that post every fortnight. If not, trouble awaits. Because, well, I guess don't make hasty promises to strangers after a few. There's a lot at stake. If he gets it wrong or can't explain his solution, he could be hounded by any of the Duke's family members or worse. But great reward too. That 10th of the 8, Irene estimates, itself could be big enough to purchase a small pony. So yes, they have the weekend to sort this out. Brian's trying out all sorts of calculations and combinations. He's scratching his head. So what is the exact portion each brother gets? Brenda is like, well, Brian, we don't know that. Then he's like, well, okay, but what the hell is the total amount then? Irene is like, come on, Brian, we won't know that either. That's what the whole challenge is about. And now it's Sunday night, and Brian's shitting bricks, for if he bricks this, he'll only be left with bricks and stones, and perhaps a few broken bones. He's panicking. He's like, come on, guys, please help me. If I know either amount, I can work it out. But how the hell do I? They're all sat at the table, sketching out all sorts of calculations, scratching out and trying again. But nothing seems to work. And then, perchance, Iris the cat turns up and sits bang in the middle of their sketches on the table. And then, after a pause, Brenda is like, hey, wait a minute. What if what each of the Duke's brothers gets is one iris? All eyes widen. Brian is like, come on, Brenda, that's silly. But Irene is like, wait, Brenda, you're on to something here. So let's see. It's one iris worth for each of the brothers, which would mean 2 iris worths for the Duke himself. But uh-oh, for the sisters it's a division. Oh, heck, we can't cut up Iris. Damn. We're done for. And Steve then goes, no, but hold on. We do not have to do anything to Iris physically. Iris is just a symbol here. Right, chaps? You don't like Iris being the symbol. What about then, say, X? Sorry, but no sorry, Elon. You can claim no credit for or ownership of this. And similarly, for the overall amount that needs divvied up, let's say we use the symbol Y. Why not, you say, eh?
Anointing the unknowns.
This, of course, is algebra in action. We have all been taught algebra in school. Many of us, most of us, hated it. All those equations, those scary unknowns, you had to move stuff around. Remember to apply operations on both sides. Yuck! Maybe many of us, as teenagers, questioned our life choices at the very sight of those equations laid out on the page, screaming, how the hell is this going to be of any use for me in life? Of course, Brian can now, after that Monday morning appearance to be sure, easily attest to otherwise. But as always in our journey of understanding innovations and breakthroughs, let's go back to the state of affairs before the birth of algebra. We saw in episode 28 how even other animals are capable of some counting, however limited. But most of us begin education with the 3 R's, with arithmetic being the R in question here. And usually, at the mention of early mathematics, we think of the ancient Greeks, perhaps more than the Mesopotamians we met in episode 24. And in particular, we associate the Greeks with geometry. In retrospect, we can even make the point that the ancient Greeks were somewhat obsessed with geometry and used it rather disproportionately, perhaps. Pythagoras, for example, is said to have first proved his famous theorem geometrically.
Picture imperfect.
But geometry had very practical uses for the ancients, especially the Egyptians. Think about it. Geometry literally means earth measuring. So, for example, each time the Nile flooded and receded, the pharaoh sent out a team of rope stretchers, or harpdinacti, to remeasure the farmlands.
The word geometry is, of course, from the Greek.
But the classical Greeks learned a lot from the Egyptians. Our triangular friend even spent some time in Egypt. Not to mention the water guy. Well, look at episode 23 for the juicy detail about him. Of course, even back then, there were challenges of having to compute unknowns, but it was limited and not systematic, not even to the extent achieved by our fictional friends above. The Egyptians and the Mesopotamians did do some complex calculating, and the Greeks we know did some rather sophisticated theorizing, or sophistry, you might say. But it was largely for specific scenarios in particular circumstances. That was it. Perhaps one reason for it was the cumbersome number systems these ancient peoples had. But also, as you and I can easily attest, geometry is easier for the simple fact that it's visual. We can imagine what is going on. After all, we are using a geometric metaphor when we say things like, "Picture this," even where there are no literal images possible. I invite you to check out my demonstration of why geometry seems easier but why it can be limiting in my article, where I explain in a way accessible to completely non-technical people, say anyone with a high school education and not much more, episode 2 in my concept series, where I explain how generative AI actually does meaning.
Symbols of progress.
But perhaps the invention of the zero and place value-based system by the ancient Indians, as I chronicled in De Numero Indorum, the episode 28 already mentioned, mattered. In contrast to the cumbersome number systems elsewhere, at least it mattered to one genius who had the acumen to immediately see the utility of the Indian numerals. And this genius is a certain dude Al-Khwarizmi, who we still celebrate with a place in our dictionary in the word algorithm.
House of Wisdom.
With the rise of Islam under the Abbasids, a recently built Baghdad soon emerged as a city of intense economic and intellectual activity, a sort of library of Alexandria of the Islamic world, soon rivaling and surpassing Nalanda, ancient India's own magnificent and prolific equivalent. The early rulers there had contact with the ancient Indians and had absorbed with great curiosity and keenness much of the mathematical advances they had made, not just the place value system, but other ancient Indian achievements, including tables of sines, cosines, and tangents, the working of pi, and so on. It's into this epicenter of great intellectual ferment that in the year 817 entered one Abu Ja'far Muhammad ibn Musa al-Khwarizmi, a Persian scholar and astronomer from Khwarezm in Central Asia, whose family, only until recent generations, likely being either Buddhist or Zoroastrian. It was al-Khwarizmi, under the patronage of the Abbasids, who went on to study the works of Aryabhata and Brahmagupta, the mathematicians instrumental in the development of the Indian numerals, as we've discussed at length, translating, for example, the mathematical treatises of the former, from his subtle but complex Sanskrit verse into lucid Arabic prose. It is said that he was delighted at the simplicity and conciseness of the numbers of the Indians, using the 9 characters from 0 to hero, I hear you say. It's Al-Khwarizmi's treatise on these numbers, which later made its way west in the Latin form, as I've mentioned, and even provided a link of, in the Algoritmi de Numero Indorum, Numbers of the Indians. However, Al-Khwarizmi also studied and potentially translated works of the Greek greats, including, in particular, Euclid, and developed a new approach combining the Greek systematic treatment with the radical new concepts introduced by the ancient Indians. This culminated in his الكتاب المختصر في حساب الجبر والمقابلة.
Can you spot the word in there?
Algebra? There it is! The compendious book on calculation by completion and balancing. The Arabic al-Jabr, making its way into Latin as our algebra.
A comprehensive completion.
It was originally not his commission to invent algebra, so to speak. Al-Khwarizmi was only encouraged by the Caliph al-Ma'mun to develop a treatise solving common problems of their day, not unlike the one I depict in the fictional account above. Things like questions of measurement of land, commercial transactions, and distribution of a legacy. But Al-Khwarizmi went a step further, fish versus fishing rod. He added a purely theoretical part to his book, where he meticulously propounded the system underlying solving such problems, giving it a solid grounding, perhaps thanks to his reading of Euclid, and in an astonishing simplicity and clarity of explanation, perhaps quite a stark contrast from the complex and possibly even obscure verse of the Indian works.
From daunting to dainty.
The reason the very sight of an algebraic equation can give many of us the heebie-jeebies is because we've burnt our fingers being forced to solve them in school, with very little context given of its relevance and utility to real life. However, algebra is everywhere. Even we, however much we might say, math is not my thing, apply it every day. The simplest example could be when you are out shopping and you are told a pack of salmon costs twice as much as tuna. You don't know the exact prices, and maybe you want to buy 3 packs. But your brain is applying algebraic equations and solving them. In this case, it is y equals 2x, where x is the price of tuna and y of salmon. The beauty of algebra is that it is possible to represent the relationships, the proportionalities between different entities, even before we know the actual quantities that will in the future be involved. And that is the predictive power I was referring to in my claim about mathematics being the queen of the sciences. So when Brian turns up in court, whether the overall sum to be distributed is a 100 silver coins, 2,500 denarii, or 12,457,600 Japanese yen, he just has to plug it into his equation, his magic formula, and out comes the x, the unknown now known. It's not hard to imagine why this is such an amazing thing. But if you're not convinced, try solving Brian's problem without resorting to algebra. But here is the reassuring part for those of who can't stand math. In reality, in other words, once we've left school, we don't need to, most of us, we don't need to come up the solution to such equations, even less come up with the equations themselves in the first place. What we need to know is to plug in the values and at the click of button, yes, literally, get the answer for the unknown. It's analogous to saying you don't need to know how to cook. You just need to know how to order what you want. Or you don't need to know how an internal combustion engine works. You just need to know how to steer the wheel. And oh yes, you don't need to know how software is created. You just need to know to swipe your phone, type your query, and click those buttons. All of these are, in essence, algebra at work, and as a step up, algorithms at work, Al-Khwarizmi's entry into our language, as that word is well burned.
Between the methods and the madness.
Another reason algebra, or math in general, can be daunting to most of us is the notational system. Even though I'm using symbols like X and Y and even plus and minus, these are part of a notational system that developed relatively recently, mostly within modern times, compared to the time span of the story of not just algebra, but all mathematics as I've covered in my writing on this specific topic. In fact, when Al-Khwarizmi wrote his treatise, he did not use any such notation as we'd recognize. Certainly not when Brahmagupta composed, in verse, his treatise introducing the zero. There were no notations. In fact, not even when the previously mentioned Leonardo of Pisa, Fibonacci, wrote about Al-Khwarizmi's work in Latin in around 1200. There was no such thing. It was all verbal, or what's technically called rhetorical. In fact, pretty much like my exact breakdown above. Of course, the reason the notation developed in modern times is because the succinctness and precision of it has immense utility. But of course, at the same time, it pushes mathematics away from something we can all relate to something rather more esoteric, certainly less accessible, daunting even. But as I've demonstrated in episode 27, where the Sanskrit grammarian, Panini, laid out his rules of how his grammar works, the notation, the precise formulation, can seem rather daunting. But, as in the example I gave simulating his approach, the way we generate an adverb and a derived noun from an adjective, something we can all do in any language we speak, can, when expressed in formal notation, look rather daunting. Check this out in action in this algebraic equivalent of the same.
Check main article for image here.
Let's also look at the actual algebraic process underlying the problem Brian and co. had to solve, as it would be formally represented and executed today.
Check main article for image here.
Going beyond the ancient achievements of arithmetic and geometry, the development of algebra stands out as a supreme intellectual achievement. Perhaps by extension, or as technical folk would say, recursion. Given my previous statement that mathematics is the queen of the sciences, we can say algebra is the queen of all mathematics. As I have demonstrated above, algebra harnesses the power of mathematics in identifying and extracting the abstract and the general from the specific and circumstantial, with the effect that it allows us to separate the method from the madness. Whatever the ultimate messiness of a given situation as and when it unfolds, we have the chance to be prepared with a handy tool, a useful instrument, a potent weapon, which could lead us to the solution. Pythagoras or Euclid, if they ever get to meet Al-Khwarizmi in a parallel universe and learn of his accomplishment, would perhaps weep inconsolably, lamenting that rather they didn't accomplish his feat. Whatever our instinctive reaction at the sight of a complex algebraic equation or at any math on the page, maybe we should be thankful to people such as the blessed Al-Khwarizmi, who developed such sophisticated tools the rest of us mortals can simply use and profit from.